Hello and welcome to the last eCHO live stream of 2024. This is episode number 165. And yeah, we're going to be looking into the crystal ball today, trying to figure out what's going to be happening in the world of eBPF, Cilium, cloud native, what's going to be happening next year. As always, wherever you're watching from around the world, we'd love to hear from you. We'd love to hear what your predictions are for next year. So do post comments, let us know where you're watching from, and join in the conversation. We're going to have quite a few people on the stream today. Hopefully, we've got a few people backstage to share their ideas for what's going to be happening in the next 12 months. And the first of those guests that I'd like to bring in is my colleague, Nico Vibert. So welcome, Nico.
Hello.
So
nice
Nico
to be
is
back.
going to be the first guest here because last year, Nico, you wrote a blog post predicting 2024. And actually, if I bring up my screen, I've got the show notes. As always, the show notes are on HackMD. Is it that corner? Can't remember whether I'm pointing in the right direction. Show notes are there. There's a link there to the blog post. So let's bring that up. Shall I accept the cookies? Why not? So Nico, how did your predictions pan out?
Well, I made loads to hedge my bets. So when you make 70 predictions, maybe one of them will turn out to be right.
It is true. There is quite a long list here. If we just look at the table of contents, there's more than fit in the space. So you definitely pulled together a lot of ideas into this review, into this prediction.
And it was covering all those things that interest me. eBPF, Cilium, more traditional networking, and an intersection into cloud native stuff, observability, platform engineering. It's been hit and miss. I feel like for some of them I was really premature. For some of them, I think I did okay. I think the one which is I think was quite relevant based on conversation I've had at KubeCon or a number of users is around the networking industry is bracing for change.
Right.
Which is essentially observing that there are lots of things going on. We see a massive rise in open source networking. We see the net DevOps movement continuing to growing in popularity. But I think what's been the most apparent is the shifts in the challenge with with the acquisition of VMware. And I'm like invested emotionally because I used to work for like six years or so. But there is, there are a number of users looking for an alternative to things like vSphere and NSX, which will have repercussions for networking, for cloud native networking. We've seen lots of people interested in KubeVirt and running virtual machine within Kubernetes, and then have some kind of networking platforms that can do virtual machine, they can do containers.
For sure. I think that KubeVirt based approach is getting quite a lot of interest. Certainly at KubeCon, we had a little session on the Isovalent booth about that, and people seem pretty interested in that as an idea. So do you think that adoption of KubeVirt is going to figure in your predictions for 2025?
Absolutely, but it's almost too obvious. I don't want to have just like things that were kind of guaranteed to happen, but we've put some content on isovalent.com around KubeVirt, videos and blog posts, and they've been very popular. But I guess the user experience, people have to kind of also realize that VMware, it took 20 years to build a product like VMware. So you use KubeVirt, it's I mean, clearly YAML based. It's not quite the same like experience where VMware you do virtual machine like vMotion and you move workloads from one place to another. It's also nice and seamless. It will take a while for the same thing to happen.
So hi to Tony, who has added the comment there that he agrees that KubeVirt will fly. I think we're all seeing that as a pretty safe prediction. Yeah, cool. Yeah. And I think another pretty key trend that we saw last year, and you mentioned already, was platform engineering. And you kind of touched on that when you talked about simplicity. I'm trying to remember where you have it in
the fifth one there. Kubernetes use.
Oh, there we go. Yeah, fighting back against complexity. Where I think a few of the points here did get somewhat tackled. For example, you talked here about the cloud landscape shrinking. We did finally see a few projects actually getting archived by the CNCF. So I think that's a really promising thing in terms of simplifying the approach. And I think maybe we're also going to see I've heard a few people talking about more kind of packaged solutions. We've seen hosted Kubernetes for quite a long time, but maybe people will be being a little bit more opinionated about some of the ways they, package things together. Tony is making a few more comments actually about KubeVirt. So I'm just going to bring those on quickly. Yeah, might be a bit rough and not well polished in terms of storage, especially. I think storage is still one of those areas that is, adds a bit of friction in the cloud native world. And he also asked, very relevant question, may I expect the Cilium external workloads integrated in some way into KubeVirt?
I mean, that's kind of what I covered as well in the a new category emerging, the heterogeneous networking. It's this kind of idea of how we need to have some consistent networking across different types of computing abstractions. It's super hard though. It's just one of the. I think it's super hard, not necessarily technically. It's because the users are different. If you're a virtual machine, administrator, it's a very different persona from, Kubernetes platform engineer, or from a cloud engineer who's maybe on the AWS console or using Terraform and stuff. So I think a platform that can kind of talk to all these different things is quite hard.
And that's very much the goal of Cilium, right? To make networking consistent across all these different platforms. So I think the answer is yes, in some way.
Yes.
Excellent. All right. So we talked about some of your accurate predictions. What, where would you like to confess to some?
Yeah. So this is the humble pie moment.
Yeah.
Well, there's one I'm happy to have been wrong, which is the eBPF misuse will lead to eBPF fatigue.
Yes, no eBPF fatigue. People are still embracing eBPF.
Still embracing. And I'm not aware of scenarios where eBPF has been intentionally misused, yet. I'm sure there are people who have created bugs because they don't really know what they're doing. They're experimenting with eBPF, and but yeah, overall, I was pretty wrong on that front. I think that was really premature. Hopefully, we have a couple more years before we hit that kind of hype, the peak hype, and people start getting frustrated.
Yeah, I mean, I really hope that we won't have. I'm sure there will be fatigue in the sense of everything goes past its hype cycle peak. I hope we're not going to fall into the trough of disillusionment, because actually the tools that are being built and the range of those tools is becoming so wide that maybe people get more blasé about eBPF rather than fatigued. It just becomes, of course we're building our tools on eBPF, because why wouldn't you? It's the way you're going to do this. So yeah, I think we're all happy that we haven't seen eBPF fatigue haven't seen even the green shoots of eBPF fatigue, so that's good. I mean, I guess the other one that we've got to call out, because it's again, I can't find it. It's the one about IPv6. I'm sure you have. There we go. IPv6 Kubernetes clusters becoming the norm.
I should have known
it. I have a theory about IPv6, which is just that it's so hard for humans to understand the addresses. You can't easily map them in your head the way that an IPv4. I mean, IPv4 is challenging enough, but it's okay. It's just about manageable. Whereas IPv6, it's really hard to look at an address and kind of understand it. And I think until it's all completely abstracted away and people don't have to look at addresses, that's my theory for why, IPv6 is not ubiquitous, aside from things like, the invention of NAT.
I think we'll ask our next guest for his opinion on this, because he's
that's a good idea. Yeah. All right. So let's add Daniel Borkmann, another iSurveillance colleague and friend. So Daniel, welcome to eCHO again.
Hello. Thanks for having me.
Pleasure.
Yeah. So what's your opinion about IPv6? Why hasn't it taken the world by storm yet?
Yeah, it's an interesting one. I think probably IPv4 addresses are still too cheap. Once they become really expensive, then maybe there's more incentive to move over. One of the predictions, I would say, for next year is probably we will see more IPv6 adoption than this year. More or less in a forced way, perhaps, because what I recently read is that 80% at least of the government or government-related entities or contractors in the US, they now are required to support IPv6. So I hope that this will be a small uptick in the IPv6 adoption. We'll see.
Mm-hmm.
Let's see. We've been making IPv6 predictions for about 15 years, and every time we've been wrong. So
I think pretty much IPv6 lands the same year that Linux on the desktop happens, isn't that? All right, so I'm going to just take away these last year's predictions, and Daniel, tell us a little bit about what you think is going to be happening in 2025.
I think one thing that was an interesting development this year, and I think it will definitely also continue at a larger scale next year, is the adoption of Netkit. So Netkit is something that we built here at iSurveillance, actually, for the Linux kernel. It's a Weave device replacement with the ultimate goal to make the pods as fast as the host namespace itself. So it's really a performance optimization. We designed this in the context of Cilium, and it's also usable outside of that, or whoever has their container orchestration mechanism. We saw this year an interesting talk at the eBPF summit from people from ByteDance, actually. They had a talk about embracing Netkit across 1 million of servers. And I think that was super interesting. They, when we merged this into the kernel, they immediately got in contact with me and said, hey, we did a POC internally. It had a 12% improvement in terms of connections per second. So they were super excited and also very eager to help out. And they gave a talk about this and what problems it solved for them in their data center. And for next year, spoiler alert, we recently published the schedule for FOSDEM for the eBPF track. My former coworker Quentin and a couple of others, Alexei, Andrei, myself, we were in the committee, and there's now a talk coming in February by Meta, where they are also going to speak about their rollout in the data center of Netkit. So we will see more adoption, and hopefully also in terms of cloud providers, like all the hyperscalers, that we can then also users of Cilium, or that they will be able to benefit as well if they are on the cloud. So I think that's a super exciting development.
Definitely. I'm going to just pull onto the screen. There is a link there, and we'll add this into the show notes as well, to a blog post on the Isovalent blog that talks a little bit more about Netkit and explains, a bit more about how it works and why it's important. And I can't remember if it's in this exact blog post, but one of the real, why this is such a big win is because it's removing the overhead. It's making the performance of container networking equivalent, to just regular host networking. So that is a game changer. So congratulations, Daniel, for building that. And I think that will have a big influence in the next 12 months and beyond. So it's going to be great to hear how those hyperscalers are really adopting it as well. Actually, interesting question here. No, before I bring the question on, I'm going to bring in our next guest as well, because why not get everybody's opinion? So let's welcome Thomas Graf. So thanks for joining us, Thomas.
Hello, everybody. Thanks a lot for having me. It's great to be on the last show of the year. I'm assuming it's the last show of the year.
It is, yeah. So hopefully we're going to nail some good predictions for what's happening in the next 12 months. So just before you joined, we were talking a little bit about IPv6 and whether or not, next year is going to be the year that IPv6 takes off. Have you got opinions about that, Thomas?
Well, it will be the same year as when it is the year of the Linux desktop.
That's what I said. They're definitely correlated.
Absolutely. It will happen, right? And we will continue to believe, we will continue to do everything we can to make it as likely as possible, because I think obviously long-term it is needed. And at some point, the layers of duct tape to do everything in IPv4 will just be too thick, and we will have to do it. But it's also hard. We all have been doing networking for long enough that we know how hard this transition is. And so I understand everybody who keeps pushing it out. It is exciting to keep working on it and seeing that eventually it will really, really, really pull through.
So talking of things like, deep networking knowledge, and also knowledge of the kernel, there's an interesting point here from Sherwood, who's saying eBPF continues to grow, but it will really fly when it becomes easier to implement your own eBPF solution. And obviously, if you want to write eBPF code, as I know from my own experience, it's pretty easy to write hello world, but you quickly start getting into the realms of needing to understand the kernel that you're interacting with. So you do need this deep kernel knowledge. So Thomas, what are your thoughts about whether eBPF needs to be easier for programmers?
I think it should become easier for programmers, but maybe not the level of full eBPF control, speaking in terms of like writing pseudo C code and directly fully understanding kernel level data structures. But I'm convinced that we will see a growing ecosystem of abstractions that make it simpler while still offering an API of some sort for programmers, right? I know there have been many attempts and many very, very useful projects in this space, from early on Python-based approaches, Rust-based approaches, all sorts of different language frameworks, some not even programming, but simply automation or an API, whether it's the Kubernetes API and so on. I think all of that useful. Sometimes it's hard to predict what exactly is the right abstraction, right? When we saw Kubernetes come around, that was a home run in terms of abstraction. So often it is about the API design that makes the difference. So I'm convinced that we will see more of this in 2025 as well. At the same time, I also enjoy that for a vast majority, using eBPF is possible through fully automated solutions, right? Whether projects that fully use the powers of eBPF and provide solutions without needing to be a programmer at all. So I think all of that is exciting. I think that is the powerful part of eBPF.
Absolutely. And I think one of the things that we've been talking about for the last, I don't know how many years, is how different projects, different products are adopting eBPF, that it's such a powerful platform for these infrastructure tools. And we're just seeing more and more and more of them. And if there is a tool that meets your needs, you don't need to implement your own eBPF solution, because somebody will have already built something that solves that problem for you.
And we were wondering as well, like beforehand, about whether AI could help us write eBPF code, right, and makes the life of Sherwood and developers easier. So, any luck in leveraging like Copilot or ChatGPT for this?
I mean, I would love if somebody would unlock the ability of AI to help finding eBPF verifier complications, like analyzing the output of the eBPF verifier if it complains, and providing assistance. Because if software engineers go and leverage eBPF directly, this is probably the biggest hurdle for many, and it requires very in-depth knowledge. It's also not something that is very simple to just incrementally improve. So automation, like parsing this eBPF verifier output, which essentially needs a little bit of assembly knowledge. Like you will be thrown at like register names, so that does not come natural to everybody, and that can be a little bit steep. So if on my wish list would be use of AI for something like this. I'm not sure if somebody has tried it, but that could be highly impactful. So maybe somebody's hearing this and we'll try this out tomorrow or over the holidays, and in January when we come back, we will have a nice AI ChatGPT based eBPF verifier assistant.
Daniel, I think you'd be playing
that would definitely be cool. I've been recently, just out of curiosity, trying ChatGPT and I asked it to build a layer 4 load balancer to just see what the outcome could be. It was definitely interesting. I didn't try to actually run the code through the verifier, but it looked very reasonable that it would be able to pass it. And it was generating like a full program, but obviously everything that comes from AI should be taken with a grain of salt, right? Not like blindly trust it. The solution actually had a couple of caveats, right? Like it was fun to see what was generated. So for example, the layer 4 load balancer that ChatGPT was generating, it would only handle UDP. So TCP, it was like a little bit too lazy to generate code for that. It used,
Did you try that? Did you change your prompt and say, now do it with TCP as well?
I should do that after. Yeah, I should still do that, yeah. And the other thing is it used a round-robin mechanism to load balance between backends. And then that round-robin mechanism writes into like a single shared counter. So it's like it didn't take performance into account, right? Like if you would actually do that in production, it will cause cache line contention across CPUs. So that's certainly something where AI still perhaps needs to learn a bit more, or perhaps I need to learn a bit more how to use ChatGPT. Maybe that's the other bug.
So I think we're going to come back to AI again. I'm sure it's going to have an influence later on. But before we go down the AI rabbit hole, I want to ask Daniel a little bit more about what he sees coming down the road within eBPF from a sort of technology point of view. If 2024 was the year that Netkit was introduced, what's going to be the new thing for 2025?
Yeah, I think we will see BPF tokens getting further adopted, for example, in the cloud native area. What are BPF tokens? So you might remember, like we disabled unprivileged BPF like a long time ago, so that like because of all the hardware vulnerabilities such as Spectre and Meltdown, where it's really super hard to make them absolutely safe. I mean, that would not be possible. It would be like a cat and mouse game. So BPF tokens is basically a delegation mechanism to be able to unlock some of the BPF subsystem functionality that you can define in that token for unprivileged applications, so that those applications that consume BPF, they don't have to have the full capabilities like cup sysadmin or cup BPF, cup perfmon and whatnot. So they can really only get the capabilities that they really need to consume. And so then this can be used to basically have this delegation and put it into your unprivileged but like trusted compute base to operate, for example, Cilium. So I'm thinking that will be like one example of adoption where we will use it in Kubernetes context.
Yeah,
So
I think
that's,
it has a huge potential for solving some of the concerns that people have about running eBPF, where it does, it comes with a huge amount of power. So addressing some of these kind of security concerns, I think BPF tokens is going to go a long way to helping with that. All right.
Yeah.
I want to also bring in, we have one more guest. We have Bill Mulligan. So let's bring Bill in as well. And we'll have a kind of all hands singing, dancing discussion of what 2025 has to bring. So welcome, Bill.
Hey, how's it going?
Yeah, good. So, Bill, what's your top prediction for 2025? Let's start with that.
My top prediction is around eBPF for security. I think basically in all the new projects, products, companies, tools around security, people are going to be baking eBPF into it. And I think we're already seeing that a lot so far. We've basically already seen the whole observability space taken over by eBPF. And I think now eBPF is coming for security next. We're already just seeing it in quite a few projects. But I think that is really just going to accelerate into 2025 based on the tailwinds of also security becoming a massive topic too. So that's my big prediction for next year.
And I think that really aligns with, so before the show, a couple of days ago, I put out a poll on LinkedIn and just put out some options for a few broad areas that might have some impact. And the 131 people who voted agreed with you that eBPF-based security tools are going to have a big impact next year. And second in the list was AI and eBPF combined. So,
which is what you voted for, right?
It is, yeah. I mean, I think there's going to be a lot of interesting things that people can do with the data that gets generated by eBPF-based tooling, whether that's, security information, observability information, spotting, anomalies in the way that a network's behaving. I can see some of those things really will lend themselves to AI, particularly anomaly detection. I think the combination of the really in-depth data that we can get from eBPF plus things like anomaly detection could have some really good use cases. And I think we're going to see some real application of that in the next 12 months. Yeah. Thomas, I don't think I actually asked you what your top prediction is for next year. So let me bring that question to you.
With predictions, I'm always following or attaching them to broader, I would say, momentum in the industry. What are overall needs in 2025? And I think eBPF will, on one hand, will follow infrastructure needs in 2025. What are problems and focus points around infrastructure? And on an infrastructure level, I think there will be a lot of focus on using Kubernetes for virtual machines. And that will quickly lead into a gigantic wish list of security, networking, observability, load balancing needs that now need to be fulfilled as VMs come to Kubernetes, and eBPF will be the obvious pick to use to fill out those gaps and fulfill the needs. I also believe that the traction that we had on using eBPF for load balancing in Kubernetes will spill out, and all of a sudden in 2025 we will see eBPF being mentioned by load balancing vendors outside of Kubernetes in the generic broader load balancing market. And my prediction would be that by the end of 2025 eBPF will be one of the, maybe not the key criteria yet, but one of the important criteria when evaluating a load balancer. And the last one, I'm 100% with Bill. Security will be an absolutely massive topic. And what I've been seeing in 2024 a lot is companies are really struggling to patch software. And I think this will explode in 2025. We will see many companies try to develop some form of AI agent, and it will be all open source based to some extent. They will construct a lot of things with open source software using AI APIs, and it will lead to a exponential explosion of software that has some form of vulnerability in it. And I think a lot of customers will look at, is there an alternative to constantly patching all of that? Can we maybe use eBPF to mitigate those vulnerabilities, not asking development teams to constantly patch so they can continue to develop fast? So that's one very specific security area where I could see eBPF have like a heavy dent, because it will just have an unfair advantage over existing technology that has been trying to address this problem so far, combined with 2025 creating an exponential need for this problem.
Absolutely. So really, that eBPF based security tools prediction, I think that's it is a certainty, really, isn't it? Yeah. Now, when you were talking a little bit more about virtual machines, Sherwood asked a related question. Will Cilium be expanded to be used outside of a Kubernetes environment?
Absolutely. And you can already, yeah, I mean, it already is to some extent, and we will extend it. It's interesting that we're now seeing both. We're seeing Cilium coming to outside of Kubernetes, and we're also seeing the outside of Kubernetes coming to Kubernetes. So we're seeing virtual machines moving to Kubernetes and coming to the existing Cilium world. So if you're using Kubernetes and you use KubeVirt to manage VMs on Kubernetes, Cilium is already there and you can already use it. Right? That's nice. But we're also bringing Cilium, load balancing and all of that to outside of Kubernetes to meet the needs there if you're not adopting Kubernetes. And then the most likely scenario is that most users will end up with a mix. So we also have to connect and secure the non-Kubernetes with the Kubernetes. So that will absolutely be our focus and what Cilium will cover as well.
Absolutely. And I think we're going to have to bring back the AI term again to comment on something that Tony has said. So if we're talking about, connecting Kubernetes networks, we're talking about connecting Kubernetes services, service mesh on steroids, AI mesh. If I was you, Tony, I would go and grab that domain name right now, because that's, that'll be worth some money. AImesh.com or something like that. Yeah. So anyone, thoughts on AI mesh?
I think what could be really interesting, where I see the biggest leaps is when AI can be used to do pattern matching on internet scale data. Right? So if we, for example, look at observability, use of observability via eBPF and AI, understanding, detecting, and making existing data more approachable based on principles that can be understood by what's documented on the internet, I can see that a lot. A very practical example would be an observability solution sees a exploit of a vulnerability, like in live data with eBPF. Now you can track this to the CV number. That doesn't make it necessarily very approachable. If you then use AI to actually generate a summary of what that means, all of a sudden you turned a low-level observability event generated by eBPF into something that almost everybody can understand. And you can even use AI to actually translate that into multiple levels of technical details. It will be significantly harder to use AI to do sort of detection on things that are not found on the internet, because then we need to train specific models. And some of these models would need to be based on maybe data that's only available in a specific environment. And all of a sudden, the investment to get there is much, much harder. So I think we'll see more application first on where we can just use public global models, right, known models, and then in a second wave, more specific models.
Yeah, absolutely. And I think that leads to something that Nico and I were talking about earlier on, about the possibility of AIs hallucinating based on, we know that hallucination is an issue in AI. Are we going to see hallucinated false positives and hallucinated, mitigations for security issues that don't actually exist, that kind of thing?
Yeah, and I think that's interesting, because even in security, we've always had both. We've always had security solutions that had to be 100% accurate. If a firewall was not accurate, everybody would complain, right? If you open that port, it's closed or it's open. But if you look at a web application firewall, it's not actually 100% accurate. It can also hallucinate. We're using different words, right? But it is also pattern matching, and it will have some probability. And then scoring is applied to actually determining and make a reasonably good decision. But there's always false positive and false negatives. I can see these same principles being applied to AI matching as well. What would be wrong is to say we're assuming and we need to apply the bar that AI needs to be 100% accurate and only use it. As you are aware, or as we are aware of, like the probability of a good or a bad decision, or missing something or misinterpreting something, scoring and other mechanisms can definitely help to work around that, but we need to be aware of it.
It's reminding me of the issue around self-driving cars, where self-driving cars are already pretty much safer than humans driving cars, but we are as a society much more accepting of the idea that humans will crash. A self-driving car crashing, that's just not acceptable. So we probably have the same kind of double standards when it comes to
that's a super interesting use case, because the way that became practical is by still having a human operator somewhat that can take over, right? If you look at self-driving taxis, they're all, to my knowledge, maybe I'm wrong, to my knowledge, they all have the backup option that if something happens, there is a human operator that can remote control and actually take action. That is this rating system, right? It does not need to get to necessarily 100% accuracy. Even 99.9 or 99 can be enough if we are aware of it and we find ways to mitigate for that inaccuracy or lack.
Absolutely. Let's get back to Bill, because Bill has tons of experience talking to people across the community and who are using Cilium and eBPF. What have you been hearing that makes you think, what are you seeing as the trends for next year?
Yeah, around Cilium. In the Cilium user survey, we asked people how they're using Kubernetes, and it was something like 95% of people are using multiple Kubernetes clusters. No one's really just running a single Kubernetes cluster anymore. And actually, in the most recent CNCF Tech Radar, Cilium was chosen as the top tool to adopt in terms of maturity and usefulness for multi-cluster management. And so I think we're really going to see the story a lot more about Cilium kind of like bringing your Kubernetes infrastructure all together, letting you to have like kind of a single way to manage and control it. Actually, literally just before this live stream, I was interviewing an end user for a case study that's going to be coming out about how Cilium cluster mesh solved a lot of their problems. It helped them kind of like simplify their stack. They didn't have to like put something else in there. They're able to easily kind of give their applications a global view of their infrastructure, reduce the complexity of their whole networking topology, and save them a lot of money in terms of infrastructure costs, in terms of like across AZ traffic and things like that too. And so I think the biggest thing for Cilium is actually going to be being able to bring all of your Kubernetes infrastructure together into kind of like one global view.
That kind of simple multi-cluster, or simplifying multi-cluster use case is super interesting, because I think a lot of people immediately think, oh, I've got multiple clusters, therefore I need a service mesh. And that just simply isn't true. You can connect your multiple clusters, you can connect services across multiple clusters using cluster mesh without introducing any of those additional kind of service mesh related type resources. So yeah, multi-cluster being really simple is one of Cilium's strengths. So I hope we'll see more use of that. Yeah.
And awesome. on a similar vein, like what I've been wondering for a long time is whether Kubernetes would become a network-aware scheduler. Because right now it schedules based on move workloads around based on like compute and storage need. But what if Cilium or Kubernetes could say, okay, I'm going to move this workload from this cluster to that cluster because my clients are located in this region, or I'll move this port from this node to this node because the network interface on that node is almost full. Like, detecting seasonality and peak traffic, this is obviously like,
maybe there's some AI involved there to understand what the best or the sort of optimal placement is going to be to take into account all these different things like locality. Yeah, interesting. Speaking of scheduling, I think that's an interesting, and I'm going to go from like scheduling workloads at Kubernetes right down to scheduling threads in the kernel, and come back to Daniel and ask about eBPF being used for task scheduling in operating systems.
Yes, absolutely. That is the latest use case that got merged into the kernel. It was merged in 6.12, where you can then build custom BPF-based process schedulers. And I think that is really interesting. Initially, I expect, or that is the process being adopted by Google and Meta and all the hyperscalers. But I think what we are also seeing is that this is being used by, for example, the gaming industry. If you think about Valve or Steam, they are Linux-based, and they so far had their own custom kernel modules to extend scheduling to their needs, so that like when you play games, so that there's always like a fast reaction, and I think that those are the first adopters outside of the hyperscalers. And I think it would also be super interesting, just to follow up on the earlier discussion, to see this in the Kubernetes landscape being adopted. And perhaps if you combine this, like with eBPF with observability to collect lots of data about how the overall system behaves and what kind of resources it consumes, I think that would be interesting, perhaps to combine this with AI and then have like the scheduler react to that, right? In order to optimize the resource usage of your cluster. I think that would be super cool.
If anybody is watching and they're from a games company that's using eBPF to do scheduling, please get in touch. We would love to hear more about that on one of these live streams in the future. That would be great. All right. While we've been talking about scheduling, Tony has been making some interesting comments about multi-cluster. So the first one here is multi-cluster, but also with multi-tenancy in the control plane with multiple data planes. Maybe Thomas, do you want to speak a little bit or react to that idea?
Yeah,
there's actually a follow-up point as well, which is I think it's in parts wasteful with resources to have several control planes when the critical data path is the data plane, and mixing in with external workloads like KubeVirt. So go back to the original question, multi-tenancy in the control plane with multiple data planes.
Yeah, this is interesting, and this will come up a lot next year for sure. I think for two reasons. Reason number one is this multi-tenancy data plane is the norm in the network virtualization world. Like Nico knows this by heart for sure. During the VM age or the virtualization age, we created hundreds of thousands of virtual networks. To the VM, they look like a layer 2 network. There is ARP. It looks like a hardware network. And it's all overlays and many of them. And in Kubernetes, we chose a different model. We chose the flat layer 3 network. And that feels normal because that is what the cloud chose. So if you go to any of the public cloud providers and you have a concept of a VPC, it will not be a layer 2 network. It will be like a flat layer 3 network. There's not really like multicast and all of these things. And with VMs coming to Kubernetes, there will be a need to bring that old concept back. So that's reason number one. We'll definitely see it. And the second reason is Kubernetes chose a model that for application developers is really natural, which is I'm scheduling my applications and I have concepts of namespaces to kind of segment them and have a Kubernetes cluster be multi-tenant. But then on the networking side, this multi-tenancy model was intentionally not enforced. It was said, like, assume that everybody can talk to everybody else, and then you can use network policies to do this multi-tenancy. And that kind of works, but not 100%, because there will always be shared resources. So I think this request has always been around that we do this, but it will be a trade-off between simplicity, which is what we have today. You can operate a Kubernetes cluster with Cilium without actually really understanding networking. You don't technically need to understand what a subnet is and what the broadcast address is and all of that. And if we go towards multi-tenancy, multi-network, we will reintroduce some of that complexity. So it will almost certainly happen, but we will definitely do it in a way that we don't impose this complexity on everybody, but it will be an opt-in for those who want it, need it, and are willing to pay the complexity cost for it.
I think a related comment is from Nguyen just making the comment, Cilium with Netkit for AI network plus Multus plus KubeVirt. Do we really need Multus for this kind of multiple network approach?
So Multus is what allows to do this right now. I would say it is a little bit duct tapey, right? Because it is not a fully integrated solution. Multus will allow to essentially invoke multiple CNIs for the same pod, but then you will not really have this full observability policy stack and so on. Typically, the trade-off is that you can have a primary CNI on one of the interfaces, on one of the networks, and you'll have observability and network policy and all of it. And you can have a secondary interface or a third and so on, which will use a much simpler CNI, whether it's MAC VLAN, IP VLAN, L2 bridge, whatever it is. That's not necessarily what I think users will want long-term. Most users we talk to, they want Cilium to essentially provide the same services and functionality across all networks, but with the multi-tenancy, with the multiple network concepts taken into account. And that is what the Isovalent product offers. So that's one area where the product offers this multi-interface, multi-network concept. And as the upstream Kubernetes multi-interface, multi-network effort progresses, we'll definitely support that via Cilium OSS as well fully.
Great. Now, you mentioned observability, and I guess one of the other, incredibly successful projects in the CNCF is OpenTelemetry. So I guess one of my predictions would be that we're going to see more eBPF generated data in OpenTelemetry format. So kind of using OpenTelemetry as the format for collecting, distributing the data that we're getting from eBPF. What are your thoughts? I mean, maybe Nico, have you seen OpenTelemetry adoption in your kind of, as you're gazing into your crystal ball?
Well, when I was writing a blog post leading up to KubeCon Salt Lake City, I came across the OpenTelemetry eBPF project, which is like combining all the buzzwords, all the exciting projects, right, within the CNCF.
Has it got AI as well? Yeah.
There's probably some AI in the mix, which I'll put the link in the show note. But it's OpenTelemetry network, and it's just leveraging eBPF to collect, low-level telemetry data. So yeah, I can definitely see a massive increase of data collected and orchestrated through OpenTelemetry.
Bill, what are your thoughts on OpenTelemetry?
Yeah, beyond just the data coming in, OpenTelemetry itself is actually adopting eBPF. So there's the network observability part that I think has been there for a couple of years. Earlier this year, they adopted an eBPF-based profiler that originally came from Elastic. And then now there's also a donation proposal from Grafana to donate Bela into OpenTelemetry 2, which is their eBPF-based auto instrumentation. So it's not only like the data itself, but we actually see OpenTelemetry itself, I think, almost re-standardizing on top of using eBPF to collect that data itself. So I think we're only going to see that accelerate, because eBPF has really taken over the whole field of observability. If you look at all the new companies and products and projects coming out, it's basically only eBPF at this point.
It's pretty exciting times for eBPF, and no pressure for the eBPF platform people in the kernel. Hey, Daniel. I guess another thing that has happened this year that can only help for eBPF adoption is things like the security audit that's happened on the verifier, threat models for eBPF starting to be produced. So people starting to really understand the kind of security profile of using these eBPF based tools. And that can only be a good thing, that that's better understood and across all levels of a security team. If you're watching and we have missed something that you think is definitely going to happen in 2025, now would be a really great time to post your comments while we still have time to talk about it.
I'm still wondering. Sorry to.
Yeah, go ahead. Yeah.
Like, do we see like a world where like an internet of eBPF or internet of eBPF things, like where your fridge is running eBPF code, or just some? I'm just throwing some wacky ideas. This is like the end of the show, so.
I mean, I would argue we're basically already there. I wouldn't be surprised if your fridge actually already is running eBPF. Like, right? Like every single Android phone in the world is already running eBPF. So we're talking about billions of devices, and probably, I don't know, half of our audience right now has eBPF literally in their hand. So I think that's pretty cool.
I would say there is. I'm not, maybe 2025 is a little bit too early, but definitely by 2026, I would say eBPF will, maybe it's not the norm yet, but it will will already take a lot of the share on securing IoT devices or devices in general, like a lot of the embedded devices, because Linux is running on all of them, right? So whether this is a Linux or a network router or a switch or a set-top box or a fridge or your security camera or your doorbell automation, whatever it is, it's all Linux based. And if you've ever looked into one of these devices, the security standards in most of them is absolutely horrible. Like, you probably won't be able to sleep anymore if you've been in there. And eBPF will be amazing to secure them. So I think whether it will happen in 2025 or 2026, I can see eBPF take a major role in securing, I wouldn't call it IoT because it's much bigger than that. It will also include data center infrastructure. It will include cars. It will include all sorts of things that are Linux powered. And billions of devices today are Linux powered. And eBPF will come in, I think, and make the entire world a little bit more secure.
It's super interesting, that idea of being able to live update, or mitigate patches using eBPF, compared to, so in a previous life, I worked on, software for embedded devices for phones, and firmware update in a hardware device is an absolute nightmare. It is so hard. It's basically, you're pretty much killing that product if you have to do a firmware update. So the ability to just run software patches that can have those that mitigate security issues in the firmware would be revolutionary, really good. The good news is, though, that regulations do mean that you can't now buy a router or something, a home router that has the password set to just password anymore. I believe that is no longer allowed. But
I think there's a talk at eBPF Summit about how somebody's using eBPF to secure like car security. I think it was around the key fobs, if I remember correctly.
It wasn't quite that, but it was super interesting. And the same person was also at OSS Summit, so I had a good conversation with him there. And it's it's really about putting eBPF into the kind of network bus in a car, which runs a different protocol. If Dan Finneran were here, he would remember the name of that protocol. But it's kind of similar to Token Ring. It's a different, different but similar approach to how they do networking. You might ask, for why don't they just use Ethernet in cars? Well, they don't. They made that decision some decades ago, and everybody uses this kind of whatever the protocol is called in
Probably
cars.
CAN bus, something, right?
Yeah, maybe. Yeah. And but yeah, they've been experimenting with using eBPF to at least measure what's happening on that bus, essentially. And I think it very much at the sort of exploratory phase, but it could be really interesting from an update perspective, for sure. Yeah.
I think this year we also saw eBPF used in exotic places. For example, like a colleague in the kernel community, he mentioned he helped a customer who deployed eBPF, or in particular XDP, on wind turbines. So he helped them debugging an issue there to get it deployed. That's one fun one. And another, I've seen a talk proposal where eBPF was used in the in astrophysics, where like I think it was from Fraunhofer, maybe in Germany, like the research institute, where they used XDP to process large data from telescopes. So yeah, super exciting.
Yeah.
To hear that.
Now, Tony has made the very clear prediction, and I think we can all get behind this one. Cilium version 1.17 next year.
And 18.
That's nailed on. Yeah. But we also have a question from Sherwood again, asking what's on the drawing board. So what is going to be coming in V17 and 1.17 and beyond? Thomas, maybe that's a good question for you.
Yeah, I think we will see a lot of, I would say, Kubernetes expanding beyond where it is today. Some of this may just be more BGP compatibility, which may sound very, very boring, but is absolutely fundamental to many of you out there, because it has to work, right? Troubleshooting day two, like ability to actually run Cilium not only at scale but also efficiently over years, while you as an infrastructure team can then actually focus on something else and maybe enlarge your stack. Mentioned VMs on Kubernetes a couple of times, absolutely. We've heard OpenTelemetry. I still feel that there is investments to be made that will definitely pay off, because looking at actual usage of OpenTelemetry, the most of it is still through application instrumentation. Most of it yet is not the transparent form of eBPF probe and collecting observability there. It's still, I'm actually instrumenting with OpenTelemetry SDKs, and because it's still, you get a little bit more. So if we can close that gap further, I think that would be nice as well. And then I think maybe to enlarge not just Cilium but also Tetragon, there is a lot for Tetragon to implement in 2025. Tetragon is definitely a couple of years behind the overall trajectory of Cilium. It's a slightly newer project. There is a lot of enforcement potential to be added on the Tetragon side. It's already amazing from an observability perspective, but we have a lot of potential left and ideas on how we can make it the best possible threat mitigation software out there.
Fantastic. One other question, along the lines of, perpetual questions that may roll on from one year to the next. Will 2025 be the year that eBPF ships in Windows?
I think the odds have never been as great. We now have the code. We have the code. It's there. So you can go in there. You can Google or search for eBPF on Windows, and you will find the code page. You can download, compile the DLL, and you can actually run it on your Windows system. You still need to put your Windows into some special development mode that you can actually do that. So the question is now, will it be elevated to be generally available, right, this year? And that will really unlock the wave. And I think 2025, the odds are really, really good. I've never seen so many different companies, vendors, including Microsoft, being fully aligned on this. But we have to understand it's also a big step, right? It's bringing a Linux technology, bringing a Linux API, bringing a Linux standard to Windows. I mean, imagine it was the other way around. Maybe Daniel can speak to that. It definitely takes a little bit of effort to sign off and say, yes, we're taking this on, right?
And one final question, since we're running out of time rapidly, is 2025 going to be the year where we see an episode of eCHO hosted by an AI?
Maybe we already are. Who knows? Yeah.
How do I know whether you're real or not? How can I tell? Well, with that, I think that's been a really interesting conversation. Thank you all so much for spending time with us this afternoon. And thanks to everybody who's been watching. Thanks for all the questions and comments. And yeah, well, let's reconvene in a year's time and see whether we nailed it.
Thank you. And thank you for hosting so many wonderful eCHO episodes all through all of 2024. It has been amazing.
Well, plenty of help from all our friends who've been also hosting these episodes as well. But yeah, I think it's been a really great year with lots of interesting guests and interesting topics. So yeah, thanks very much. Happy holidays to everybody if you're watching, and have a wonderful new year. And we will see you in 2025.